Hey, what's up guys? Welcome to online lecture number 2 of Math 18A College Algebra. Sorry, I know there's a really bad glare right here. I don't really know what I'm going to do about that yet, so my apologies. So last lecture we finished chapter 2, actually, so today we're going to be starting chapter 3, which goes more in depth on polynomials. And I have an updated calendar, so I'll be posting that online like today, so you guys should see it by the time you're watching this video. So let's go ahead and jump into 3.1.
Okay, so first we're going to talk about quadratic functions. And let's first just remember some of the things that we've already learned about quadratics. General form looks like this: ax squared plus bx plus c. And using our function notation, we can write it as f of x equals ax squared plus bx plus c, or you can write y equals. They're both the same thing. They're both functions of x. And one of the other things that we talked about was the graph of a quadratic function. We talked about it briefly. And remember, it's kind of just that bowl shape. But it depends on the sign of this leading coefficient here, right? So based on the sign of a, positive or negative, that is. Based on the sign of a, your graph either opens pointing upward or pointing downward. And so if a is positive, if a is greater than 0, then you have that upward facing bowl shape like this. And if a is negative, you have the opposite thing. You have your downward facing bowl. This is called a parabola. That's how you describe the shape of this graph. It's called a parabola. And this point here on both of these is called the vertex. Same thing here, vertex. And one of the things to notice is that if you have this upward facing parabola, the vertex is the minimum. So here it's the minimum. Remember we talked about relative maxes, relative mins. And then on the downward facing one, the vertex is the maximum. And so this maximum and minimum quality being at the vertex is good to keep in mind for solving word problems, because very often in like physics, if you have a physics word problem, you'll be modeling like the trajectory of a particle or of some object, and it'll be parabolic like this. And if it asks you to find like the highest height that it reaches, then you'll know that it just occurs at the vertex of this parabola. And so given some quadratic equation or quadratic function, how can we find the vertex? Because we've seen that it's important, so how can we find it using our equation? And so here we introduce a new form to write our quadratics in, called standard form or vertex form. And so that looks like f of x equals a parentheses x minus h squared plus k. And if your quadratic equation is in this form, then you can actually just pull the vertex right off of this equation. The vertex is going to be the ordered pair h comma k. So if we start in general form, like we typically do, ax squared plus bx plus c, there is a method that gets you from general form to standard form or vertex form. And that method is called completing the square. Now I want to show you how completing the square works, and then after I'll show you a shortcut on how to find the vertex of a parabola. Completing the square gets pretty algebra heavy, so if you're going farther in math, it's a good thing to know how to do, but otherwise it's okay to just use the shortcut that I'll show you. So let's start with our quadratic equation in general form, like we have here. And we'll first take our c to the other side, so we'll subtract it from both sides. So I have y minus c on the left-hand side now. And on the right side, I'm just left with ax squared plus bx. Next, we'll divide the whole equation by a, so I can isolate my x squared. So divide everything by a, meaning this left side too. X squared plus b over a x. And so we take this b over a, and that's what we're going to use to figure out our completing the square term, basically. So we take our b over a, and we divide it by 2. So that gives me b over 2a. And then I have to square it. So just square this whole thing, raise it to the second power, b over 2a squared. Next, I need to add this term to both sides of my equation. So we're going to be adding b over 2a squared to both sides. So here I've just copied what I had previously, and I'm going to add my b over 2a squared to both sides. So b over 2a here, squared, and here as well. And I now want to start simplifying this expression. So the left-hand side, I'm going to first split up this fraction into y over a minus c over a. And notice they have the same denominator, so if I combine these, you'll get back to exactly this. I'll keep my b over 2a squared the same for now. And then the right-hand side, so I chose this b over 2a so that I could factor this right-hand side into a perfect square. So this is going to factor into x plus b over 2a squared. And you can FOIL this out, and you'll see that you end up with exactly this. So that's why we chose this b over 2a term here. So on this left-hand side, let me simplify this a little bit more. Y over a minus c over a. And then I'm going to square this now. So I'm going to have plus b squared over 4a squared. Keep the right-hand side the same for now. And then I'm going to combine these two terms, this minus c over a and this b squared over 4a squared. So that means I need to get this to be to have the same denominator. So I already have an a here. I need to multiply by 4a on the top and bottom so that I can get to 4a squared for a denominator. Again, the right-hand side will stay the same. And then I'll combine these into one fraction. So y over a plus b squared minus 4ac over 4a squared equals x plus b over 2a squared. And to write this in vertex form or standard form, let's see, where do I have it? Like this form. I'm going to want to solve for y, because f of x is the same as y here. So my goal is to solve for y here. So I'll first take this whole expression to the right-hand side. Let me make a new page. So y over a And then, what did I have? I'm going to be subtracting this over here. So I'll first just copy this term. X plus b over 2a squared minus this whole thing here, b squared minus 4ac over 4a squared. And then the last thing I have to do is isolate my y, so multiply the whole equation by a. So that way I'll get my y by itself. I'll get an a on the outside here. And then this a will cancel out with one of the a's in my denominator here. So I'll just end up with b squared minus 4ac over 4a. And this is actually how you derive the quadratic formula as well. If I had decided to solve for x instead, I'd get the results that you get from using the quadratic formula. So this probably looks absolutely hideous to many of you, and that's okay. But we did achieve what we wanted. We wrote this expression in vertex form or standard form, and so I can now pull the vertex right off of this as the ordered pair negative b over 2a. I have to reverse my signs. I'll go back to the original equation in a minute here. And then negative this whole thing, b squared minus 4ac over 4a. So let me go back to my standard form here, because it's minus h and it's plus k. So, because I have plus here, it's going to take the negative sign, and because I have minus here, it'll take another negative sign to make it positive. Or, alternately, you can just take this x-coordinate, because this is the x-coordinate of your vertex. Negative b over 2a. And whatever your original function was, in general form, ax squared plus bx plus c, you can just plug this in for into your f of x. So like f, you evaluate it at this negative b over 2a, and that'll give you the y-coordinate of your vertex. And I'll show you some examples without so many variables, so with like actual numbers, and then it should make more sense after that. Okay, so let's take a look at an example that I pulled from one of the past final exams. F of x equals 3x squared minus 12x minus 21, and we're supposed to write it in standard form, or vertex form, and sketch the graph, and then label the vertex and the y-intercept. So I'll first do it by completing the square. And so when I do completing the square, I like to rewrite it using a y instead of that f of x, just because it's nicer to do algebra on y. Minus 21, okay. So then the first thing that I want to do is take this minus 21 to the other side. And to do that, I have to add 21 to both sides of my equation. Right, so then I have y plus 21 equals 3x squared minus 12x. So then next, I want to isolate my x squared here. So I have to divide both sides of the equation by 3. And make sure you do it to the whole equation, both sides by 3. So basically, like this, like this. So I would just leave this side like this for now. Y plus 21 over 3 equals, be careful when you reduce here. You have to reduce both of these terms, not just one of them. Like this, very often people like to just reduce the 3 with that and leave the 12x, but you're not allowed to do that. You have to make sure you reduce all terms by this 3 here. So if I reduce the 3 here, I get x squared. And then reducing the 12 in the 3, 12 divided by 3 is 4. So I have minus 4x. Okay? So then I want to look at this minus 4 term here, because that's what I'm going to be using to complete the square. So take your minus 4. And first you have to divide it by 2. Which gives me negative 2. And then you have to square it. So negative 2 squared is 4. So that's my special completing the square term. I now want to add that to both sides. So add term to both sides. So my left-hand side was y plus 21 over 3. And I have to add this 4 that I computed. Do it in red, plus 4. And then back to the other side, I had x squared minus 4x. And I have to add the 4 to that side too. And so I'll start simplifying this side. Like I like to do here, I like to write it as 2 different fractions, separate it. And then I have to factor this right-hand side. But it always factors very conveniently, it always becomes a perfect square. So I'll have x, and then I have this 4, so it becomes a 2, but be careful with the sign, because it's a minus 4x here, you need a minus in between. So it's always like square root this, square root that, and then be careful with your sign depending on the middle term here. So then let's simplify the left-hand side a little bit further. Y over 3, 21 over 3 happens to be 7. It doesn't always divide nicely, but conveniently it does here. So plus 7 plus 4 equals, leave this side the same. Combine these terms right here, my 7 and my 4. 7 plus 4 is 11, so plus 11 equals, still keep it the same here. And then at this point I'm trying to solve for y, right? So I need to move my 11 to the other side, so let's subtract it from both sides. Cancels there. I have y over 3 equals x minus 2 squared minus 11. And the last thing that I need to do is multiply the entire equation by 3 to get rid of that 3 in my denominator down here. So the whole thing will get, that looks like an exponent. The whole thing will get multiplied by a factor of 3. So let me go to the next page. I had y over 3 multiplied by 3, so it cancels, so I just have y. My 3 has to distribute to both of these, okay? So make sure you're careful on that as well. So it'll go on the outside of my x minus 2 squared. And then minus 11 multiplied by 3. So it's going to give me minus 33. Okay, so this is standard form right here. And then I was supposed to graph it. So let's go ahead and do that first. Oh, you know what? Actually, before I do that, let's figure out what our vertex is. Whoops. Because that'll make it easier to graph. So vertex, remember, I can just pull right off of my equation. This is my h and k, so my vertex is going to be 2, and then negative 33. Which is like way down in the negative y direction, so I'm going to need kind of a long graph. This is like x, this is y, they all have arrows. And then, for sake of time, I'll just go like down here and label this as negative 33. So I know that my vertex is this point here, so I will have a point at negative 33, at 2 comma negative 33, and that's going to be my vertex. And then from there, check the sign on this. It's positive. So you would call that the leading coefficient still. Positive leading coefficient. And that means that my parabola points in the upward direction, right? So it's going to look something like this. But before I sketch that, why don't we were also asked to find the y-intercept, and that'll give me another point to plot on my graph. So let's do that first. So y-intercept, remember, the y-intercept is the value of y when x equals 0. So that means that all I have to do is plug in 0 for x. So I can plug that in right here. Or you can plug it into your original equation, but I'll just plug it in here. So y equals 3 times 0 minus 2 squared minus 33. So 3 times 0 minus 2 is negative 2. Still squaring that, subtracting 33. So 3 times negative 2 squared. This negative 2 squared is actually 4. So I have 3 times 4 minus 33. Let me go like over here. So 3 times 4 is 12. Take away 33. That's going to give me negative 21, I believe. You can always throw that in your calculator if you're not comfortable doing subtractions like that. So then my y-intercept is negative 21, which means I cross the y-axis at negative 21. So I'll plot that. Let's see. This is like 33. This will be like negative 30. Then negative 20 is like here. Negative 10 is like here. You just have to scale it so that it works out. So negative 21 would be right here, essentially. So then I know that my parabola has to cross through these points, and it has to be symmetric on either side. So I'll do my best to draw the graph. Nope. Very skinny. Like that on that side, and then exactly the same on the other side. So very thin. So it's not perfectly symmetric, but this would be fine to graph, like to write as your answer like this. And so we just have to label our vertex to negative 33. And our y-intercept here, that's going to be at 0 because we plugged in 0 for x, and negative 21. Okay, so now let's try the same problem, but we'll use our shortcut method, where I can just figure out what my vertex is by finding the x-coordinate first, given by negative b over 2a, and then plug in to find the y-coordinate. And I actually didn't know about this method until teaching this class, so it'll be interesting to see how much faster it is. So first, let's take our negative b over 2a. So here, that equals, b is negative 12, right? Make sure you keep your sign. This would be a, this would be b, this would be c, with the sign. So negative 12 over 2a, a is 3. Negative and negative makes positive 12, right? And then over 2 times 3, which is 6. 12 divided by 6 is 2. So I can already check. I did get the correct x-coordinate, so that's good. And now we can find the y-coordinate by plugging in our x-coordinate. So plugging that into this f of x equation, f evaluated at 2 equals 3 times 2 squared, plugging it in right here for x squared, minus 12 times 2, minus 21, gives me 3 times this 2 squared here is going to give me 4, minus 12 times 2 is 24, and then minus 21. 3 times 4 is 12, minus 24 minus 21, and then just going left to right, 12 minus 24 is negative 12, minus 21, so that gives me negative 33. So then my vertex again is, or I'll keep it in black, vertex 2, the x-coordinate, and then negative 33, the y-coordinate. So exactly the same. Perfect. And then to find the y-intercept, again, remember that the y-intercept is the value of y when x equals 0. So I'm plugging in x equals 0 again. Plug it into f of x. So f of 0 equals 3 times 0 squared minus 12 times 0 minus 21, I believe was the last term here. Yes, right. Okay, so 0 goes away, 0 goes away, so I end up with negative 21, which is what I got for my y-intercept in this one too. So now I have the points that I need. I have my vertex was 2, negative 33. And my y-intercept, you can write it as a point also, 0, negative 21. And then I can do the same graphing process. This is x, this is y. We'll actually label our stuff a little bit nicer, maybe negative 20, negative 30. So I can label my vertex again first. 2, negative 33, so around here. And that's 2, negative 33. And then I can plot my y-intercept. 0, negative 21, so right down here. And remember, it's just a rough sketch. It's not going to be perfect. That's okay. So that's my y-intercept. And then again, I just have to draw, better this time. And then symmetric on the other side, because parabolas have to be symmetric. So there we go. We got the same thing, and it was a bit faster. So yeah, go ahead and use that method if you're comfortable with that instead. Okay, so the last example I'll do today is one from your textbook. It should be in your homework problems. The path of a diver is given by y equals negative 4 over 9x squared plus 24 over 9x plus 10. So notice the leading coefficient here is negative. So we see this downward-facing parabola, where y is the height in feet, and x is the horizontal distance measured from the end of the diving board. Find the maximum height of the diver. So it looks something like this. Here's your diving board. Your diver goes like this. This isn't really the diving motion, but I can't really draw a diving motion, so whatever. He goes into the pool, and we want to find the max height. So it's going to occur at this vertex here. So we'll use the methods that we've learned to find the highest point that the diver achieves. And so here, since our expression is pretty heavy on the fractions, let's just not complete the square. It doesn't seem like it's going to work out very nicely. And instead we'll just take our shortcut and do the negative b over 2a to find the x-coordinate first. So here I've just copied our equation that we had, and we want to find the maximum height, which occurs at the vertex. So I'll start by finding the x-coordinate of my vertex, which is given by negative b over 2a. And so here, my b is 24 over 9, so I'm taking negative b, negative 24 over 9, and dividing it by 2a, where my a here is negative 4 over 9, so plugging that in here. And let's first simplify this denominator here. I don't like having the parentheses with the 2 multiplying on the outside, so leave the top the same for now. And remember, 2 is just 2 over 1. So I just multiply the top, multiply through by the, on the top and the bottom. So 2 times negative 4 is negative 8 over 1 times 9, so just 9. And I know a lot of us aren't quite comfortable dealing with these weird expressions quite yet, so I wanted to do another example of that. So I like to start by writing this as a division of fractions. So it's the numerator divided by the denominator, so negative 24 over 9 divided by negative 8 over 9. And so remember, when you're doing division with fractions, division with fractions, you just have to multiply by the reciprocal. And remember, the reciprocal, hopefully I can fit it here, kind of. The reciprocal is just you take this and you flip it, turn it upside down. Right, so this is actually just the same as negative 24 over 9 times the reciprocal of negative 8 over 9, so negative 9 over 8. Okay, and then from here, it's really nice to simplify in this multiplication process. So notice I have a 9 and a 9. I can kill this 9 with this one. And then 8 actually divides into 24 evenly, so this can go away and cancel, and this becomes 3. And then keep your negative signs around too, so this is actually negative 3 and negative 1 here. And I'll have a negative times a negative, which makes it positive 3. Because everything else went to 1, right? Everything else canceled out. So I actually just have 3 here. So that's the x-coordinate of my vertex. So from there, all I have to do is plug that in to my equation for x, right? So I want to find the y-coordinate. Y equals negative 4 over 9 times 3 squared plus 24 over 9 times 3 plus 10. And so we'll simplify that. Negative 4 over 9, 3 squared is also 9, plus 24, I'll rewrite this part too. 24 over 9, this is times 3 over 1, plus 10. So here it might be nice to simplify a bit as well. I can cancel this 3 with this 9. This becomes a 1 and this becomes a 3, right? Because 3 goes into 9 3 times. And then here as well, this part is just 9 over 1. So I have 9 in the numerator and 9 in the denominator. These are going to cancel out. both become 1. Okay? I'll just go over here. So this became 1, so now I just have -4. I reduced this 3 and this 9, so this is plus 24 over 3 and plus 10. Simplifying this a little bit further, 24 over 3 is actually just 8, because 24 divided by 3 is 8. So -4 plus 8 plus 10, which you can just throw this into your calculator now. -4 plus 8, that's going to give me +4. +4 plus 10 is going to give me 14. And the height was in feet. So this is the maximum height that he reaches. So let's go back to our picture for a second. And notice that we started at 10, so it does make sense that he went up to 14 feet here. And if you kind of like drop this down, like along the x-axis, the x value is 3. So you can see it does look about correct. You go over 3 and you go up to 14. So yeah, his maximum height was 14 feet. And we found that by finding the vertex